Hello and welcome to this lesson on trigonometric functions. I'm Mohamed Kadem Karé. The PDF of the lesson may be downloaded from the website I indicate here. The outline of the lesson will be firstly to define cosine and sine functions, then to give their remarkable values. After that, I will define the tangent function, and finally, I will show you how to solve equations with trigonometric functions. Let's now define the cosine and sine functions. Before giving the definition of cosine and sine function, I present what is called the trigonometric circle. So consider the plane with an orthonormal frame here, O, U, V. So U is the vector on the abscissa axis and V is the vector on the ordinate axis. And consider a circle with center O and radius 1. On this circle, we shall give also or define a direction which is called the trigonometric direction here, which is the opposite of the clockwise direction. So we say that the trigonometric direction is counterclockwise. Now, for any point M on the trigonometric circle, let's consider the length of this arc here in the direction defined previously. This length is what is called the angle between the vector u and the vector OM. Let's denote it x. Then, for the point M, if you consider its abscissa, it is called the cosine of x. And if you consider the ordinate of the point M, it is what is defined as the sine of x. Let's formulate this in mathematical terms. So the plane is provided with an orthonormal reference frame, OUV. Consider the circle C with center O and radius 1, which is called trigonometric circle. Let A be the point with coordinates 1, 0. So we remind that the counterclockwise direction is called trigonometric direction. And for any point M on the circle, let x be the length of the arc AM in the trigonometric direction. We say that x is the angle between U and OM, and it is denoted like this. So this notation here is the angle which we denote by x. In this case, the coordinates of M are called cosine and sine of x, and they are denoted cos of x and sine of x, respectively. Now, we define the cosine of x plus k 2 pi as equal to cosine of x, and similarly for sine, for any k in z, the set of relative integers. We say that the functions cosine and sine are periodic with period 2 pi. Here are the basic properties of the cosine and sine functions. Firstly, the cosine and the sine are between -1 and 1. Secondly, the cosine squared plus the sine squared equals 1. Moreover, the cosine function is even, which means that cosine of -x equals cosine of x, and the sine function is odd, which means that sine of -x equals minus sine of x. Finally, the derivatives of the functions considered here are as follows. The derivative of cosine equals minus sine, and the derivative of sine equals cosine. So please keep in mind that there is a minus sign here. Here is an argument to prove that the sine function is odd. So if we consider an angle x here, minus x is the angle in the other direction, which gives this angle here. So sine of minus x is this value I show with this line. So you see that sine of minus x equals minus sine of x. I will state now many properties which have not to be memorized. They can be retrieved easily from the trigonometric circle. For example, cosine of pi over 2 minus x equals sine of x. And sine pi over 2 minus x equals cosine of x. Moreover, cosine of pi over 2 plus x equals minus sine of x, etc. You can read all these properties, and now I will show you how to retrieve them from the circle. Let's consider an example to illustrate how you can retrieve easily these formulae. Consider an angle x here. So its cosine is this value. Consider now the angle pi over 2 minus x, which gives this angle here. Okay. So you see that the sine of pi minus 2 minus x, this value here, equals the cosine of x. So this is a way to retrieve this equality from the trigonometric circle, but all the other properties may be also retrieved. For example, sine of pi over 2 plus x, which is this angle here, equals also cosine of x. Also, cosine of pi over 2 minus x, which is this value here. So this cosine here of this angle equals minus sine of x. Since it is in the negative direction, so it is minus sine of x. Now I will give you the remarkable values of cosine and sine functions. Here are some angles for which we have explicitly the cosine and sine values. For example, the angle 0 has cosine equals to 1 and sine equals to 0. The angle pi have cosine minus 1 and sine 0. Also, the angle pi over 2 have cosine equals 0 and sine equals 1. So this may be shown easily on the trigonometric circle. So I try to draw it correctly. Okay, so for the 0 angle here, you see that the cosine equals 1 and the sine equals 0. For pi, you see that so this is the angle pi, you see that the cosine equals minus 1 and the sine equals 0. So this is the angle pi. Now, if we consider pi over 2, so I erase this. So let's draw or consider the angle pi over 2, which is this angle here. So this is the angle pi over 2. You see that the cosine of this angle equals 0 and the sine of this angle equals 1. Okay. There is a last angle for which also we can deduce easily the sine and the cosine values. I try to erase this. Okay. It is pi over 4. So let's draw again the y-axis and consider pi over 4, which is this angle here. So this angle, pi over 4, has the property that its cosine value and its sine values are equal. So my figure is not completely correct, but this value here a is the same value here a. But since a squared plus a squared equals 1, then we get the value of a is necessarily equal to square root of 2 divided by 2. And you see that these two values are equal. Now, in the next slide, I will show you how to retrieve the values of cosine and sine of pi over 6 and pi over 3. Here is again the trigonometric circle. Consider firstly, for example, the angle pi over 6, which is the angle here. You see that the sine of this angle comes here in the half of this segment, so the sine of pi over 6 equals 1 over 2. For pi over 3, you see that its cosine again comes in the middle of these 2 points, so cosine of pi over 3 equals 1/2. Now you can use the fact that cosine squared plus sine squared equals 1 to deduce that the cosine of pi over 6 here equals square root of 3 divided by 2. We now define a third trigonometric function called tangent function. The tangent function, denoted tan, is defined by tangent of x equals sine of x divided by cosine of x. And this is defined for any x such that the cosine is not 0. So it is defined for any x within the set of real numbers minus pi over 2 plus k pi, where k is a relative number. Here are the basic properties of the tangent function. Firstly, tangent of x plus pi equals tangent of x. So the tangent function is periodic with period pi. Moreover, the tangent function is odd, so tangent of minus x equals minus tangent of x. And finally, the derivative of the tangent function equals 1 plus tangent squared. Please keep in mind all these properties. In the last section of this lesson, I will show you how to solve equations with trigonometric functions. The objective is to solve an equation of the type cosine of x equals cosine of alpha, where x is a real number, an unknown, and alpha is given. To this end, we shall use the trigonometric circle to find the solutions. Let's firstly show the case of cosine. So we draw the trigonometric circle here. And I plot some angle here, x, or alpha more precisely. So we see that cosine of alpha equals cosine of minus alpha. These two angles, alpha and minus alpha, have the same cosine. So the equation cosine of x equals cosine of alpha holds if and only if x equals alpha or minus alpha, of course always plus the usual term k multiplied by 2 pi. Similarly, if we solve now the sine equation, I will plot half of the trigonometric circle. So if I take an angle here alpha, we know by the trigonometric circle that alpha and pi minus alpha, which is this angle here, pi minus alpha have the same sign. So the equation sine of x equals sine of alpha holds if and only if x equals alpha or x equals pi minus alpha, again with the usual term plus k multiplied by 2 pi. And finally, tangent x equals tangent alpha if and only if x equals alpha plus k multiplied by pi, where k is again a relative number, a relative integer more precisely. This is the end of this lesson. I hope it was clear and useful for you. I wish you a good day and see you in the next lesson. Goodbye.